Hello guys, how are you? This is Hans Haway once again. In this video we're going to be looking at the relationship between mass and weight. We are saying weight is the force of gravity acting on an object, and weight is directly proportional to mass. The formula which combines weight and mass is this one. W is equal to mg, right? Where W is the weight in newtons, M is the mass in kg. Remember, it has to be in kg. Then G is the strength of gravity in Newton per kg. So the strength of gravity towards the surface of the earth is taken to be 10 Newton per kg, right? We all know that when we jump high up, or when we throw something upwards, the object that is thrown upwards, or ourselves when we jump upwards, we eventually come down, and the object also eventually lands down to the ground. And the reason for that is that the gravitational force pulling us and the object towards the center of earth, right? Every object is pulled towards the center of the earth. So what I want us to do now is to look at the questions and solve them. So that's the most important thing, is for us to be able to solve question, right? So here are our examples. Question number 1. Determine the weight of each body below from the given mass. Take G as 10 Newton per kg. We have A. We see an object of 5 kg. B, 500 grams. As always, first things first. First things first, my friends. No exceptions. The first thing that we need to do for A is to write down the data. Data is the information that is being given that will help us to determine the weight. Determine the weight. Well, weight is equal to question mark, right? From the given mass, G is equal to this. So G is equal to 10. For A, mass is 5 kg. M is 5 kg. So now, looking at this data, I have to be thinking with given variables here, quantities, can I determine weight from them? The answer is yes. W is equal to mg. So W is equal to mg, which is M5 times G, which is 10. And what do we get? 50, right? Therefore, weight is equal to 50 newtons. So weight acts vertically downwards from the center of mass. We shall look at center of mass shortly. So the weight acts from the center of mass, or center of gravity, right? So that's the weight, which is 50 newtons. So let's look at B. For B, once again, we cannot forget, right, to write down the data. So with the data, things becomes a little bit simpler, okay? So determine the weight once again. W question mark. G is given as 10, right? And then M. What is M? Okay, for this one, we have to be careful. We have been omitting units to make our calculations a bit simpler and tidy, but we sometimes want to include them so for clarity, right? For instance, for this question here, the mass is in grams, but when we go back to our equation, we see that the mass has to be in what? In kgs, in kg, right? So 500 gram to kg, what do? We divide by 1000. We divide by 1000. That we should know. 500 grams are actually kilograms. Kilo means 1000, so 1000 grams. So this is 500 grams, which means it's a half of 1000. So we divide this by 1000, and then what we get is 0.5 kg. So we get 0.5 kg. Right, from that, weight is equal to mg. So it is equal to mg is equal to, I'm going to include the units, 0.5 kg times 10 Newton per kg, right? So what happens here? Kg cancels kg, right? Here 1, here 1. So what do we have? W is equal to 0.5 times 10 is 5, right? 5 what? The kg has been cancelled, so we are left with Newton here. So as you can see, if we include the units, we make our things really simpler. Our units, we can actually see what is going to happen. So, but sometimes we don't need to include units for maybe to save space and time, right? But when things becomes a little bit tougher or confusing, we include units. So if you can just practice including units, it will make your life a bit easy. Can be a long route, but it will be easy, right? So if you are to show the weight, you're going to start from the center of gravity of center of mass, then you show this is the weight. You can include the value there. So that's it. Let's look at question number 2. Well, here is number 2. The boy below has a weight of 600 Newton. Determine his mass. Take G to be 10 Newton per kg. Once again, data. So data is everything. Data is everything, my friends. So the boy below has a weight of, I'm teaching you how to take data, right? I've seen most students struggle to take data. So I'm just doing step by step. The boy below has a weight of 600 Newton. Here is a numerical value. And that numerical value is the what? The weight. So I'm going to write it. W for weight is 600 Newton. Let's include units this time again. 600 newtons. Determine his mass, M, because we are to find the mass. So it's a question mark because we don't have mass. We are to calculate it. So they are telling us, here's the hint. Take G to be 10 Newton per kg, right? G is 10 Newton per kg. So here it is. So as you can see, I have included everything which has been provided for us. So we are to find mass. So can we find mass given weight and gravitational strength? Yes, because from this formula here, we see that there is m, there is w, there is g. Therefore, we can use this equation. So let me go and write w is equal to m g. Okay, we can change subject of the formula straight away, but what I've realized with most of my students, they like putting values, so I'll just go and put values. 600 newtons is equal to m, put the multiplication sign, 10 newton per what? Per kg. So what do we do? What do we do here? We can, what do? We divide both sides by 10 newton per kg because we want to get rid of this. We want to have m on its own, right? We want to liberate it from this. So we are going to divide both sides by this value here. So let me change the color. Well, we'll divide both sides by 10 newton per kg, 10 newton per kg. So having done this, what do we do now? Oh, we can just go straight away and cancel this because this into this one and this into this is 1. Then when we get here, what do? We can start with units for newtons. We're dividing newton by newton. So what do? They cancel out, right? From there, 0 cancels 0, right? This 0 cancels 1 0 there. So what do we have now? We have, so this will come out to be 60 kg. I think we will look at how we work this out when we are looking at graphs, because now I don't want to confuse anyone, but this is similar to dividing by a fraction. Okay, I can just maybe do it quickly. Okay, let me first write down the answer as m is equal to 60 because we have 60 here, the units, and newton is cancelled. We're left with kgs. We might also know that mass is in what? In kgs straight away, right? So here now we are saying when an object is taken to another planet, its weight will change because it depends on the gravitational strength, g, but mass remains the same. Mass does not change. That's one thing we should always remember. Mass remains the same, right? Here's an example. A spacecraft travels to the moon where the force of gravity is 1/6 of that on Earth. The mass of the spacecraft as measured on Earth is 4,000 kg, right? Determine its weight on Earth. So now we're looking at solutions, right? Solutions. So A, remember, we take data. So the mass of the spacecraft as measured on Earth is 4,000 newton, right? So m, I'll write, okay, let me just write m. On Earth is 4,000 kg, right? Determine its weight on Earth. W question mark. So as we have specified On Earth, the gravitational strength is 10 Newton per kg. So this is 10. So we are to find weight. Can I use mass and gravitational strength to find weight? The answer is yes. So W is equal to mg. M is 4,000 kg, right? Times 10 Newton per what? Per kg. So kgs, they cancel out. What am I left with? 4,000 times 10, that is 40,000. 40,000 what? Here is the unit which has been left out when we cancel kgs, which is Newton. So the weight for the spacecraft as measured on Earth will be 40,000 Newton. So B mass on the moon. What is the mass? Mass remains the same. So mass is 4,000 kg, right? It doesn't change. It will always be the same. C, determine its weight on the moon. Data weight question mark, right? The mass remains the same, remember, is 4,000. Then G is G where? M. I'm putting a subscript M to remind myself that this is the gravity on the moon, and I might also write subscript M. Why? To remind myself that the weight is the weight on the moon, right? What are they saying about it? The force of gravity is 1/6 of that on Earth. So is 1/6 of 10, because 10 what? Newton per kg. We know that on Earth is 10, so it's 1/6 of this, right? So I can find this out separately. 1/6 times 10 is equal to, that is 1.66666. Yeah, that's it. So then after getting this, what do I do? Weight on the moon is equal to mass, which is constant, is the same whether on moon or on Earth, right? Times G on the moon. So to find weight on the moon, I'm to use the what? The gravitational force on the moon, which is 1.6666. I'll just put maybe up to 4 digits after the comma. 0 times 1.66667, right? Which is equal to, so it is very important to remember that you only round the final answer, right? 666.66666. So we can then write this to 2 or 3 significant figures. Let me choose 2. 700 Newton. Correct to 2 significant figures, right? So this is corrected to significant figures, 6,700 newtons. So that's it about mass and weight.